Hello, it's Mr. Westwater here, and I'm going to talk you through the single pure mock paper from Thursday morning. So let's get straight into it. Question 1. We have a line with equation 8x, so let's say 8x plus 4y minus 5 equals 0, and we're being asked to work out the gradient. So I know that if I write it in the form of y equals mx plus c, I can just read off the gradient straight away. So let's try and make y the subject of this equation. So if I take away 8x and add 5 to both sides, I'll end up with this, and then dividing through by 4, I'll have minus 2x plus 5 over 4. I mean, this isn't really important, this 5 over 4, but this minus 2 is my m. Okay, so this is my m. So my gradient is minus 2. Okay, B. The line L2 is perpendicular to L1 and passes through the point 4, 6. Find the equation of L2 in the form of y equals mx plus c. Now, if two lines are perpendicular, then their product is going to be minus 1. So minus 2 times minus a half. Oh, sorry, not minus a half, just a half is going to equal minus 1. So our perpendicular gradient is going to be a half. Okay. The other way of thinking about this is take your value of 2, flip it so it now becomes 1 over 2, or minus 2, and times it by minus 1, and that will also give you your perpendicular gradient. So we've got our gradient, we've got a coordinate which was 4, 6, so I can sub it into the formula y minus y1 equals mx minus x1. So where x1 and y1 are our coordinates, so that would be x1, that would be y1. So y minus 6 is going to equal a half of x minus 4. Okay, if I multiply both sides through by 2, this will be, in fact, no, I don't want to do that. Because we want to keep it in the form of y equals mx plus c. We don't want y to become any bigger. So let's expand the brackets. Y minus 6 equals a half x minus 2. Okay, so I've expanded that bracket, and now I can add 6 to both sides to leave y equals a half x plus 4, and that will be my final answer. Okay, so that is L2, so let's just label this as L2. Okay, using algebra, find all real solutions to the equation a to the 4 minus 2a squared minus 80 equals 0. Now, it might not look like it, but this is a quadratic in disguise. If we say a squared equals, I don't know, capital X, for example, then a to the 4 is just capital X squared. 2a squared is just 2x, and 80 would stay 80. And now this is a quadratic we can solve a lot easier. So if we factorize this, 80, what's that going to be? 10 and 8. So x, we want a 10, we want an 8, we want a negative 2 here, so the larger number is going to be negative. Equals 0, and from this we can read off that x equals 10 or x equals minus 8. And remember, we said that a squared equals x, so we can change this now to a squared equals 10 or a squared equals minus 8. Now, this will have no real solutions because you can't square root a negative. Okay. But this, however, if we square root, will have a plus or a minus root 10. Okay, and we can just leave it like that. Okay, question 3. We have this equation y equals the square root of x plus 4 over x plus 4, where x is greater than 0. Find in the simplest form dy by dx. So the first thing we need to do is rewrite this where everything is written as a power. So the square root of x we can write as x to the power of a half. 4x to the minus 1, well that's the same as 4 times 1 over x, isn't it? Add 4, so this is the same as x to the half, add 4 times x to the minus 1, add 4. Okay. And if we differentiate that, times by the power, so a half times x, and then take away 1 from the power, a half take away 1 is minus a half. And same thing again, so 4 times minus 1 will be minus 4, and then take away 1 from the power, minus 2. And our plus 4 at the end will just sort of disappear. So there is our simplest form of dy by dx. We could rewrite it if we wanted to as a half times 1 over the square root of x, or 1 over 2 root x, and this minus 4 times 1 over x squared, or minus 4 over x squared, but I think that this is probably fine for our final answer. Okay, and hence find the range of values of x for which the curve is increasing. Now, if the curve is increasing, oh, actually, I've made a little mistake there. I've labelled this as just y, haven't I? Whereas actually, this is dy by dx. Okay, so this curve is increasing when dy by dx is greater than or equal to 0, or it might, or you could get away with saying dy by dx is greater than 0. Both of those are acceptable sort of approaches, but we're keen to show this. So let's take our formula for dy by dx and plug it in to this inequality. Okay, it's greater than or equal to 0. Now, this might seem like it's a bit overly complicated, and most people, when they had a go at this, when they made mistakes, just made it a bit too hard. If we think about this as 4 over x squared, well, whenever we've got a fraction in an equation, a good strategy is to multiply through by the denominator of that fraction. Yeah, and as we've got an inequality, if I times both sides by x squared, okay, 0 times x squared will just remain 0. In fact, what I could even do is write it as a half x to the minus half is going to be greater than or equal to, if I add 4x to the minus 2 to both sides, I can think about it like that. And this is a half x to the minus half is greater than or equal to 4 over x squared. So what I'm going to do is I'm going to multiply through by x squared. So x to the minus half times x squared, we'd add the powers, and this would become x to the 3 over 2. So x to the 3 over 2 half is going to be greater than or equal to 4, and if I multiply now through by the denominator of the left-hand side, I'd end up with x to the 3 over 2 is greater than or equal to 8. Okay, so x is going to be greater than or equal to 8 to the power of 2/3. So x, and would normally carry on writing down in a column, but on this one occasion I'm going to write my answer here. X is greater than or equal to 4. The cube root of 8 is 2, and then square it to give you 4. Okay, question 4. We have the equation y equals k over x squared plus 2. Right, x is in the reals and does not equal 0. Sketch C stating the horizontal asymptote. So let's start off by drawing some axes. Okay, it's just a rough sketch. Now I know that 1 over x looks something like this. So what's going to happen if I make this 1 over x squared? Well, all of the negative values are going to be made positive. Okay, so it's not going to sort of lose its shape. It might get stretched a little bit. Okay, but it's going to hold that sort of shape. Okay, and then if I add 2, so if I have add 2 to this, all that's going to happen is the graph is going to shift up 2. Okay, so what I'm going to do, actually, I'm going to cheat. And I'm just going to move my axes down. Okay, and I'm going to say that this line is now my asymptote. Okay, so let's make it a dotted line. Okay, and we should always label these lines, and the question I think does ask us to. So this is the line of y equals 2. Okay, and if it's k over x squared, it's just going to look like this, because before we would have shifted it up to, it would have been stretched, and that would have resulted in it still sort of holding the same shape. A few interesting answers came in where they said, well, if k is negative, then actually the graph you're going to end up with is going to be like this, but actually be flipped upside down. And this is true. Okay, so that's if k is less than 0, whereas this is the graph of when k is greater than 0. This is actually what we were looking for, but if you wrote something like this, as the question doesn't state that k has to be positive, it just says that k is a constant, I think this is just as valid an answer. Okay, so let's have a look at B now. Oops. Show that the x-coordinate of any point of intersection of L with C is given by the solution of this equation below. And so the line L has the equation y equals 2x plus 5. So let's make a note of that. Y equals minus 2x plus 5. And our original equation was y equals k over x squared. Ooh, whoops. Y equals k over x squared plus 2. Okay, so if we're looking at where these graphs intercept, we can start equating them to each other. So they both equal y, so I can replace the y over here with this equation. So I could say minus 2x plus 5 equals k over x squared plus 2. And again, multiplying through by the denominator, I would end up with minus 2x cubed plus 5x squared. It's going to equal k plus 2x squared. And now I can start thinking about what my end game is. Well, I want k to be positive. So let's bring everything over to the right hand side. So I could say 0 equals k. I'd need to take away 5x squared, so this would now become minus 3x squared. And if I add 2x cubed to both sides, we end up with the equation that we're after. Okay, so let's move on to the next question. Okay, so circle. We have an equation of a circle, and we're being asked to find the coordinates of the centre and the exact radius of C, leaving your answer as simple as possible. And it's also asking us to show working clearly, so let's make sure we put in all the steps. Now, the key process here is to try and complete the square to break up this circle. So if we group the y's and the x's together, like this, we can start looking at completing the square for x. So that's going to be x plus 3, halving 6, and then take away the 3 squared, so minus 9. And if I do the same for y, we'll have y minus 2, half of 4 squared, minus 4, that 2 squared. We've still got that plus 5 at the end, so that equals 0. And if I neaten this up, x plus 3 squared plus y minus 2 squared. Now I've got minus 9, minus 4, add 5. That's going to be minus 8 equals 0. It's not quite in the form I need it, so if I add 8 to both sides, I can now read off my centre is going to be at -3, 2, and my radius squared is 8. So r is going to be the square root of 8. Now it does ask me for the radius as to be expressed as simply as possible, so let's just neaten that up. That's going to be 2 root 2, or root 4 times root 2. Okay, so let's just leave our answer very clearly. Centre -3, 2, radius 2 root 2. Okay, I think that was I, and that was I. B. The straight line with equation x equals k, where k is constant, intersects C at 2 distinct points. Find the range of possible values for k. So if I think about this graphically, okay, so our centre is -3, 2, that's around about here, and my circle is just going to go around that point, something like that. Okay, so the line of x equals k is going to be along the x-axis, and it's going to be a vertical line up. Okay, now if it has 2 distinct points, it's going to be anywhere between the rightmost point of that circle and the leftmost point of that circle. And as we know what the radius is already, that's 2 root 2, and we know where the centre is at -3 here, we can say that it's not going to be anywhere past this point or this point, which is -3 plus 2 root 2 and -3 minus 2 root 2. So we can say that k is going to be anywhere between those two values, so -3 plus 2 root 2 and -3 minus 2 root 2. Okay, it's not going to equal those points, because at those points there'll only be one solution, and our question says that there are 2 distinct points. Now, some of you did have a go at this by trying to use the discriminant and sort of trying to equate those two equations in a similar way we previously did up here, where we equated these two equations. And once you use the discriminant, if you say that the discriminant is greater than or equal, or just greater than 0, you should end up with these as your solutions as well. Okay? So you do get the same answer. Right. Question 6. Show that 10 cos squared x minus sin x minus 7 over 2 sin x minus 1 is always equal to -3 minus 5 sin x. Okay, so this is going to be a proof question, or a show that question, so we need to start from one side and work our way towards the other. We cannot manipulate both sides at the same time. So let's start by saying that the left-hand side is 10 cos squared x minus sin x minus 7 over 2 sin x minus 1. Now I'm looking at my final answer and there's only sine there, so I'm starting to think maybe I should try and write everything in terms of sine. Now if I think back to sine squared x plus cos squared x, well, that equals 1, so I can replace cos squared x with 1 minus sine squared x. So I'm going to say that 10 is now times by 1 minus sine squared x. So this is a clear demonstration and showing that I am using one of the identities. Okay, over 2 sine x minus 1. And let's expand that out. That's 10 minus 10 sine squared x minus sine x minus 7 over 2 sine x minus 1. In fact, what I'll do, I'll keep on listing these equal signs to show that I'm working on it as I go. And if I group everything together, I now have minus 10 sine squared x minus sine x. And then I've got 10 minus 7 is 3. Okay, over 2 sine x minus 1. Now, I'm not a huge fan of negatives in front of my squared terms. So first off, we have to note that this is a quadratic. Okay, so it might be worth you thinking of this as minus 10 x squared minus x plus 3 if you want to. And if we do start thinking about it like that, I'm going to try and times everything by minus 1. So I'm going to say this is minus 1 times 10x squared plus x minus 3. Just because it's then easier to factorize. Okay, so let's think of sine x. Oops, let's make it lowercase x as capital X. And so this top will become minus 1 times 10x squared plus x minus 3. And the denominator is going to be 2x minus 1. I'm just going to add another page because I think I'll probably need it. Okay, so let's factorize this now. So we would have minus 1 still on the top, and this is going to be 5x and 2x and minus 1 over here and plus 3. Yeah, so 5 times minus 1 is minus 5, and then if we added 6x, then we'd get that plus 1 in the middle. And I sort of used the question to help me along here, because I know that actually all along we're going to want to be cancelling something. So I knew I was trying to build one of these brackets to be the same as the denominator. So I knew that one of them was going to be 2x minus 1. And that will now just leave me with minus 1 times 5x plus 3, or minus 5x plus, oh sorry, not plus, minus 3. And remember we said let sine x equal x, so this is minus 5 sine x minus 3, which is what we needed to show. Or it was minus 3 minus 5 sine x, so maybe we should write equals minus 3 minus 5 sine x, which equals our right hand side. Okay, so there I am. I've finished working from my left hand side all the way down to the right hand side. Okay. Okay, just a sort of note, and that's how I get back to sine x. Okay, question 7. Prove from first principles that the derivative of x to the 4 is 4x cubed. So if I'm using this from first principles, I'm going to start talking about the limit as h tends to 0 of not f of x plus h, but x plus h to the 4 minus x to the 4 over h. Now, I can use the binomial expansion for this first part. So if I use the binomial expansion, this is going to be x to the 4 plus 4x cubed, h on its own. And then I would have to use my calculator to do 4 choose 2 or something like that. And that gives me a value of 6. So this would be 6x squared h squared. Okay. And due to symmetry, we'd now start working back. So this would be xh cubed and then plus h to the 4. And I've still got that minus x squared, oh sorry, minus x to the 4. on that far side, all over h. So what's going to happen? Well, as I mean, the brackets aren't really doing anything here, so actually let's get rid of them. Well, the x to the 4s will actually cancel with each other and leave me with just 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the 4. Okay, over h, and now the h's will cancel, won't they? So this will just leave me with 4x cubed plus 6x squared h squared, well, not h squared, just h now. Okay, add 4x h cubed, no, I've done it again, h squared, add h cubed. And now this is where our and now this is where our proof comes in. We say as h tends to 0, we can start saying that, well, 6x squared h will tend to 0. This 4x h squared is going to tend to 0, and this h cubed is going to tend to 0. So our expression, so if we say, let's call this f dashed of x, okay, we can say f dashed of x is going to tend to, or is going to equal just 4x cubed. Okay, question 8. We have a graph. It is the graph of y equals 3 sine x. So it's our normal graph of sine x, but stretched by a factor of 3 outwards. And we're being asked to state the coordinates of P. Well, this is normally at 90 degrees. We are working in degrees. Now, normally sine hits at 1, but if it's been stretched out by a scale factor of 3, this is now going to be at 3. So the coordinates of P are going to be at 90, 3. And that's I. And for part 2, what are the coordinates of Q? Well, remember it's one full cycle to get back to where we started, so that's 360 degrees, and then we've got another 180 degrees to get to Q, so that's going to be 540 altogether. So the coordinates will be 540, 0. And the curve, a different curve C2 has the equation of y equals 3 sine x plus k. So it's the same as this, but it's shifted up by a value of k. And we're told that the maximum value of y is now 10. So actually, if it's gone up to 10 at the point P here, then this is shifted up 7. Okay? So actually, I know what k is. K is 7. The point R is the minimum point on C2 with the smallest positive x coordinate. So that will correspond to this coordinate down there. So let's think about what was this coordinate originally. Well, this would have been 270, and this would have been -3. So this has been shifted up 7. So -3 will now be up at +4. So I can say that this is going to have the coordinates of 270, 4. Okay. Right, question 9. The straight line L has the equation y equals k 2x minus 1, where k is a constant. The curve with the equation y equals x squared plus 2x plus 11, curve C has that equation. Find the set of values of k for which the line L does not cross or touch C. So again, we need to set it up so they're equaling each other. So we could say k times 2x minus 1 is going to equal x squared plus 2x plus 11. Now, if we're trying to solve this, we would want to make it into a quadratic. So let's start thinking about what this is going to look like as a quadratic. So that's going to be 2kx minus k is going to equal x squared plus 2x plus 11. And grouping terms on one side, 0 is now going to equal x squared plus 2x minus 2kx plus 11 and then plus k. Okay, so what I've done is I've also grouped the x's and the constant terms together at the end. Okay, so these are our constant terms and these are our x's because they're going to be important in our next step. What I'm going to do now is I want to write it in the form of ax squared plus bx plus c. So this is, well, I've got all of my x squared terms together, but if I now factorize x out, so this is going to be 2 minus 2k x, and then plus 11 plus k at the end. Okay, so this is going to be, a is going to be 1, b is going to be this 2 minus 2k, and c is 11 plus k. Now, if they do not cross, then our discriminant, this b squared minus 4ac, is not going to have any solutions. So this is going to be less than 0. So let's sub in our values of a, b, and c into this. 2 minus 2k squared minus 4 times 1 times 11 plus k is less than 0. And expanding this out, remember this is double brackets, will give me 4 minus 4k minus another 4k plus 4k squared. And then 4 times 11 is going to be minus 44. And then minus 4 times k is going to be minus 4k. That's going to be less than 0. Let's start collecting all of our terms together now. So I've got 4k squared, I've got minus 12k altogether, and I've got minus 40 in constants. Now I'd notice here that everything is a factor of 4, so a multiple of 4 I should say. So let's divide everything through by 4 to neaten it up. Okay, minus 10 is less than 0. And now I'm thinking about these values. Now this is going to create a quadratic equation, which is going to pass through 2 points, and we're looking where this is less than 0. Okay, it's going to be a U-shaped parabola because our constant in front of k is positive. And positive graphs, quadratics, will always create that smiley face. So let's find our critical points. So we can do that by just solving this equation. So let's factorize this. I'll just move this down a little bit. Okay, so k minus 5, k plus 2. So k is going to equal 5 or minus 2. So those are my values, minus 2 and 5. And again, remember, we're looking at where this graph is below 0. So it's going to be between those two values. So k is trapped between, and I would write it as one single inequality because it's representing one single region. If I was representing two separate regions, like the outside region, I would write it as k is greater than 5 and k is less than minus 2 as two separate inequalities. But because it's one region, it's important we write it as one single inequality. Okay, and that would be my solution. So those are my set of values of k. Okay, question 10. We have a graph, and f of x is shown in figure 4. The curve C and has a single turning point at 4, 9, crosses the coordinate axes at only two places, at -3, 0 and 0, 6, and it has a single asymptote at y equals 4. So we're being asked, state the equation of the asymptote to the curve with the equation y equals f of minus x. Now y equals f of minus x is going to be a reflection, and our question is it going to reflect vertically or is it going to reflect horizontally? Well, whenever something's inside the brackets, it's going to move in the horizontal direction. Okay, so our graph is going to look something along the lines of what it did before, but in reverse this way, so like that. Now the asymptote of y equals 4 is actually still going to stay the same. So my answer to A, y equals 4 is still going to be the equation of that asymptote. Now, let's have a look at B. State the coordinates of the turning point on the curve with the equation y equals 1/4 x. So again, it's inside the brackets, so it means we are moving in the horizontal direction. And it also means we sort of do the reverse of what we would anticipate. So 1/4 would actually mean we stretch it outwards by a scale factor of 4. Okay, so this coordinate here of 4, 9 is going to move out. So the x value is going to now become 16. It's been stretched out. But 9 will stay the same. So my coordinate for B is going to be 16, 9. Okay, given that the line with the equation y equals k, so that's going to be a horizontal line, where k is a constant, intersects C at exactly 1 point, state the possible values of k. Right, so it's going to hit at exactly this point here, at 9, okay? So k could equal 9. And then every bit below that value, yeah, it's going to hit 2, 2, 2, 2, 2 until we get to this asymptote. Because this asymptote, our line doesn't ever touch that asymptote again at this point onwards. Okay, but it does still cross it at this value here. So at 4, it will have one crossing point, and actually all the points below 4 as well will have one intersection point. So I can say k can also be less than or equal to 4. And now let's have a look at D. So the curve C is transformed to a new curve that passes through the origin. Okay. Given the curve has equation y equals f of x minus a, state the value of the constant a. Now this is a translation, so it's just everything has been shifted down by a. So this will mean this needs to travel 6 downwards, so a is going to equal 6. A little note that it would not equal minus 6 because the minus is already there for us. So this would be our answer to part I. And then part 2. Write down the equation for another single transformation of C that also passes through the origin. Okay, now a stretch of any kind is not going to do it because it can get very close but it won't ever touch. But another translation, but this time in the horizontal direction, will get us there. So that's a shift of 3 to the right. So that is f of x minus 3 will take us 3 places to the right. Okay. And final question. So, question 11. On the 31st of December 2014, the government implemented a charge on plastic bags in an attempt to reduce the rising use of these bags and the environmental impact this has had. In N years after the change was implemented, the government targeted for the number of plastic bags to be modelled using this equation, where X is the number of plastic bags in billions used during the preceding year. Calculate, according to the model, how many bags were being used in the year ending the 31st of December 2014. So that's when it started. So that's going to be n equals 0 for this particular case. So let's just say A here. So this is going to be x equals 7.6 minus 0.2 brackets 0 minus 2 squared. Okay, and if I type that in on my calculator, 7.6 minus 0.2 times minus 2 squared. Okay, let's type that in. I get a value of 6.8. Now, because these questions are in context, it's always important to make sure your answers are in context. So X is the number of plastic bags in billions. So let's say 6.8 billion plastic bags. Okay, let's move on to B. So find the year when the bag usage was expected to be at its highest. Okay, now this is going to mean, so yeah. Okay, B, so find the year when the bag usage was expected to be at its highest. Okay, so this is actually modelled on a quadratic, and it's in the form of a completing the square form. Okay, and n is actually going to be negative because of this minus in front, so we're going to have this sort of n-shaped quadratic, and this represents a shift of 2 to the right here. So my turning point is going to be when n equals 2, and actually the peak is going to be 7.6 straight away. And if you're familiar with how to use completing the square to draw graphs, it's a very quick tool to help find these values quickly. So n equals 2 at that particular case. Another way of thinking about it is you want to take away the smallest amount possible, and that's going to be when this whole amount is 0, because otherwise you're always going to be taking away something as you're squaring whatever is in this bracket. So if no matter what n is, it will be positive once you square it, even if you take away 2. So the year we need to talk about. So n equals 0 is 2014, n equals 1 is going to be 2015, n equals 2 is going to be 2016. And how many bags were predicted to be used in the year found here? Well, that's just going to be 7.6 minus 0, as we mentioned before, so that's going to be 7.6 billion plastic bags. Oops. Okay, C. In the year ending the 31st of December 2018, so that's going to be n equals 4. Yep, n equals 4. 7 billion bags were used. Evaluate whether the government were meeting their target at this point and justify your answer. So let's use our formula and sub in n equals 4. So 7.6 minus 0.2 times, we said 4. Did we say 4? Yeah, 4 minus 2 squared. So that's actually going to be exactly the same as our starting equation, because minus 2 squared is going to be the same as 2 squared. So I can save myself a little bit of time typing this in on my calculator and say that this comes out at 6.8 billion plastic bags. So this was our target. And what did we actually do? Well, we had 7 billion bags. Okay, so reality, 7 billion. So let's say the target was missed, because we actually wanted fewer plastic bags. Okay, and finally, explain why the model will not be valid in 2025. Well, in 2025, n is going to equal 11. So let's see what happens when we sub in 11 into this formula. 11 minus 2 squared. So I'm typing this in on my calculator now. 7.6 minus 0.2 times 9 squared, that's 11 minus 2. And that gives me minus 43 over 5, or minus 8.6. Okay, so this is a negative amount. Okay, it doesn't make sense. You can't target using a negative amount of plastic bags. So that's it, 54 marks out of 54. I hope this was helpful. Thank you very much.